Can I start? Okay, thank you. First of all, thank you very much for allowing me to talk in this setting. This is a joint work with Tommaso Tornese, who is at Bocconi University. Essentially, the question is, if you wish, it's a policy question, to a certain extent also linked to the forecast. No? Essentially, we had this huge increase in energy prices. What are the implications for inflation and output? Obviously, if the transmission mechanism is different, then you can easily make forecast errors if you use, for example, linear model. The same standard sentence here applies. These are the views, my views, and not those of the European Central Bank. So these are the questions. Is there a differential effect of the transmission of the retail energy price shocks on price and output when an economy is in a low and high inflation regime? It's kind of similar to what we saw in the with Fabio Canova. He was looking at monetary policy shocks. Here we're looking at energy supply shocks. It's similar, very similar setting. How fast is the transmission of the shock, the speed, and then the question of symmetric effect. Does transmission depend upon the sign and the size of the shocks? Very similar questions that we saw yesterday. The empirical analysis based on individual good prices support these micro-founded state-dependent models of nominal rigidities. There are theoretical literatures by Alvarez, Lippi, and others. Essentially, what is found is that in the empirical literature is that the prices changes infrequently. Prices are more flexible in response to large shocks. Price change more frequently when inflation is high. So you can clearly see from these micro studies that there is some nonlinearities. However, there is a little empirical evidence using aggregate prices. No? We look at HICP, for example, in the euro area. There is not much evidence. There is some work by Ascari and Haber in the Economic Journal. They use, however, local projections, and it has been quite criticized heavily by Kilian, Gonçalves, and others. They say that when you use in nonlinear setting, when the state economy is endogenous, the local projection estimator of the response functions tends to be asymptotically biased. Now, the literature, energy supply shocks through oil shocks and linear framework is plenty, like possibly Chromatrix is born with identification of oil supply shocks. On retail energy supply shocks, a linear framework, also it's there. Kilian did some work on this, obviously, and also there are some new papers coming out due to this new energy crisis. One with nonlinear oil models, there are a couple of papers by Olmodulla and Ubrik, our colleagues at ECB. Ubrik is no longer with us. They use a macro switching VAR, but they did not distinguish the source of all price shocks. Mumtaz instead use some restriction to identify demand and supply all prices using a threshold VAR with some restrictions. Also, nonlinear models have mushroomed recently. The traditional T-VAR, threshold VAR by Balke, I think Balke is the first paper, looking at credit condition shocks. Then we have Mumtaz that I mentioned, Canova that was presented yesterday. There is a large number of papers on smooth transition VARs, so the literature is long, but none of them look at energy of all shocks. Macro switching VAR and also quantile VAR by Manganelli. These are the type of nonlinear models that we have in the literature. What we do here, we fit here in the threshold VAR, and we estimate a retail energy supply shock. So this is the model. It's, if you wish, this is the transmission mechanism of the VAR in a low inflation regime when the transition, the state variable is below a certain threshold. And this is the transmission of the VAR when in the high inflation regime, essentially when the state variable is above the threshold. There is a real little trick here, STUT, that is basically suggested by Lenza Premicieri in order to take into account for the COVID period, because we estimate the model until June 2022, and what Lenza Premicieri suggests is that this ST, so essentially is to take into account the data in the data, is essentially to is setting ST equal to 1 before March 2020. So this is like, if you wish, the threshold VAR estimated by Canova before March 2020, and then taking different values, S0 in March, S1 in April, S2 in May, and then gradually, there is these estimations also of the rho that essentially you have, once you estimate S2, over the entire sample period thereafter, there is this scaling effect is declining. Now, the way they estimate S0 is published in the Journal of Applied Econometrics. They use a Pareto distributions with the scale and shape parameters equal to 1 in order to take into account for the variances of the VAR innovations. And for rho, the prior is a beta distribution with the mode and standard deviation of 0.8 and 0.1. So we essentially copy this piece of code in our setting. So we don't make any change whatsoever. And I was impressed myself that the results are reasonable. But in the working paper, we estimate this model until 2019-12, and then out of sample we do. So we take essentially the transmission mechanism estimated until 2019, and then we do the exercise out of a sample. The referee asked us to do everything in sample, and so that's the reason why I was surprised that the results are quite similar. Right. So we identify shocks using sign, magnitude, and narrative restrictions, using also Ruben Ramirez, Anton Diaz, Ruben Ramirez suggestions, but refrain from applying the importance weighting step as suggested by Giacomini, and we compute what I would call a nonlinear impulse response function. We mentioned also with Canova, that's the same. Essentially, it is a simulation where you have the baseline in absence of shocks, and then you add the shock, the difference between the two gives you the impulse response function, and the state depends on when the shock starts at time t to define the law in the inflation regime. But then when you move forward, you can shift the transitions from one to the other. Right, it's an empirical work. There is no theory, just a basic principle. It's here in terms of data, the advantage compared to the rest of the literature, we really focus on retail energy prices. For prices, we take energy HICP. It includes electricity, gas, liquid fuels, solid fuels, heat energy, and fuels and lubricants for personal transport equipment. That's what is available, because the current crisis is a gas crisis. It was not an oil crisis. So you cannot really use oil prices to estimate or provide an answer to the policymakers over the last 2-3 years. At the same time, we want to focus on dynamics in the area. It's not a global model. No? When you have an oil price shock, it's the global economy. You have people use, for example, global oil or industrial production. No, we here instead focus euro area, and we take into account, we use energy productions in the euro area. So again, this mining acquiring of energy producing materials, manufacture of coke, petroleum, distribution of electricity, gas. So it's a very comprehensive measures focusing on retail energy production. The other variables that we consider is HSCP, which is key, real GDP, which is key. It's a monthly model because I do believe that you better identify shocks using monthly variable, particularly if you introduce a narrative restriction. So I think monthly does a better job than quarterly. Therefore, we interpolate real GDP, but we also use industrial production. And if you want to focus on economic activity based on monthly data, industrial production, then we have also the shadow short-term interest rate from Knipper. Estimation sample is from January 1990 to June 2022. It's a 6 lags because we are going to use August 1990 as a narrative. It also reduces, as Canova mentioned, it takes huge amount of time to find rows and to estimate this model. When you reduce the number of lags, it helps a bit. So also this is also the reason. But the key reasons is a technical one because we need August 1990 as a narrative because of the Gulf War. We use Minnesota prior and time initial observation prior to account for possible configuration. The model is in level essentially. And that is the state variable. The state variable, this is HICP, and this is HICP inflation, and we take an exponential weighted moving average. Okay, why we do that? I think that Canova used year-on-year growth rate. Okay, he did not mention, but I believe that's what is the underlying. We want to take into account that also inflation at minus infinity count. right? So it's essentially taking into account, obviously there is a decay parameter. Now, the advantage of this is that you can write it like a var. Okay, so it's very easy to compute, particularly when you compute the generalized impulse response function. You just have to write this. It's with the lag, with the one lag, so it's very simple rather than having to count for 12 lags. With one lag, it's straightforward. So that's also the technical reason why we do that. Now we need to calibrate alpha, and such that alpha is, we can minimize the gap with the year-on-year inflation. Okay, and we set alpha equal to the calibration allows, gives us alpha equal to 12.5, and you can see that the correlations between year-on-year inflations and our exponential weighted moving average is 97%. So it's you cannot distinguish between the two. This one is headline inflation, HICP. This is our state variable. So only in some period is a bit smoother, but the correlation is very high. Now, what about the threshold? Now, we use what is the technical term? The search grid in order to maximize likelihood, and we get 2.05, 2.06, right? So we decided to go for the median, and the median is 1.98%. So it's the same thing, right? The advantage of taking the median is essentially it's 2% the median. It's close to the search grid for maximum likelihood, and you get exactly the same number of observations in high and low inflation regime, right? So remember that was my questions to Fabio. You have only 36 observations in the high frequency regime. I mean, are you worried? I was worried, right? So that there could be some differences. So we go for the median. I think we also have answered to the policymaker. They are worried when inflation is above 2%. We also estimate the model in the robustness check with 2.2 being above 2.2 being inflation. Results are the same. But anyway, at least the results do not depend on the number of observations. Right. So this is the sign management restrictions. I mean, here we also estimate these other two shocks. The demand shock is not needed. There is a paper by Canova saying that if you identify the shocks, the credible set improves for all of them. We do 3, that's fine, but we can certainly drop. The demand shock is not needed. Now, the key point is the energy supply, I would say, and other supply shocks. Even other supply shock actually is not really needed, but anyway, that's what we do. And essentially, we impose that after energy supply shocks, energy HICP rises, headline HICP rises, energy production declines. For other supplies, we don't have any restrictions, and therefore this bulk is not identified with some restrictions. It is identified through magnitude restrictions. Essentially, what we say is that when in the presence of an energy supply shock, the energy supply shock explain most of the forecast error. So explain the amount of the forecast error value decompositions at impacts explained by energy shocks is larger for energy HICP than headline HICP. Okay, and the opposite for the other supplies. For the other supply shocks, we assume that this shock is able to explain most of the forecast error value decompositions for headline HICP relative to energy HICP. In this way, the system is essentially identified. We also impose some narrative restrictions, and the narrative restrictions are selected. The first two are selected from the paper by Caldara Iacovello, together with the work of Kanzig. So if the shock of Kanzig is positive, and if the shock by Caldara Iacovello is very large, when we take it on board. And this is the case for the Gulf War and for the Venezuela strikes on the oil sector. This increased our retail energy prices. What we are assuming is the shock should be positive in these 2 months, and that they explain they have the largest contributions to the one-step ahead forecast error of energy prices. So this is the narrative identifications that suggested by Roberto Ramirez in terms of approach. In addition to these two, we also add the gas cut from Russia in October 2021 and November 2021, and the Ukraine war, okay, which increased prices. So that's the way, essentially, we identify the system. In the working paper version that is published, we don't do this. This was forced us by the referee now. We did not, impose much of so it was very blunt, the sign restrictions. So there was no restriction on HICP, for example. There was no, we went through the narrative restriction only. It was working fine. The results are very similar. But the referee forced us to have a complete, following the Druber-Rabin approach, that essentially you need that the model is fully identified with sign restrictions and then reduce the credible set through narrative restrictions. And now we are doing this. But the results are strongly valid, even if you drop all this infrastructure and you basically focus on normalizing HICP and using the narrative restrictions. The results are, in spirit, they are the same. Okay, so this is the linear model. HICP energy rises. It's a one standard deviation shock. Interesting, HICP, you have this shape there. It's not immediately transitory. There is an arm shape there. The shadow wage rate then declines. GDP declines. Industrial production declines. Energy productions, it's in negative territory. And this is the estimation with the threshold bar. Here, here we show the period between January 1997 and 1919. You can see that the standard deviations, most of them are below 1 and -1. So it's 90% of the shocks are less than 1%. This is in line with many papers, Killian in premise, suggesting that this is sharp increase in oil prices in 2005-06, I think, it was driven by emerging markets demand shocks rather than supply shocks. So this is essentially is confirmed by this. Now you can see that the scale is very different. You reach 6. The energy supply shock is above 5 for the Ukraine war. On average, between October and June 2022, you get a 1.4 standard deviation shocks every single month that has been hitting the economy. Now, if we look at the impulse response function, in blue, it's the low inflation regime. In red, it is the high inflation regime. Let's focus on the blue, which is, you get, it is normalized. The normalization is very important. We're assuming that the supply shocks increase energy prices by 10%, and hereby decrease energy prices by 10%. Let's focus on the adverse shock. And then you see that in the low inflation regime, HICP, it's truly transitory. Also, the impact on the HICP is transitory. You have a negative impact on GDP, negative impact on industrial production. Energy production is also negatively affected. There is obviously some restriction there playing a role. And also the shadow rate, on average tend to be negative, although the credible set include 0. Now, if we look at instead the high inflation regime, it's very interesting that also the HICP energy, there is a differential effect between the two. The transmission is much stronger. Okay, it takes much more time to return back, right? So the gap on HICP is huge between the two. Therefore, if you make a forecast based on this IRF, you make a huge forecast error, no? So that is the bottom line, and many of us have done this mistake. Now, GDP does not decline immediately. It takes a long time before it goes to negative value. The same is for industrial production. The effect is almost symmetric, although not really so, but I will come back to that. If energy prices decreases by 10%, let me provide you these multipliers for the size and for the sign, because otherwise it's complicated. Here we take the peak or the trough impact, and then here are the results. So this is the linear model that you have seen before. So this is the drop in economic activity, and this is increasing prices. Remember that energy prices account for 10% in the weight of the HSCP. So this is this 1.1. It's related to the fact that it is the kind of related to the weight of the energy HSCP in headline inflation. Now this is the rise all over. So you see the differences between a low and high inflation regime. We have discussed this before. Now, if we take this is all the shocks, all these numbers are comparable among them because they're all normalized. So, we consider this 10% increase or decrease in energy prices, right? So even this 40% is comparable with 10%. Otherwise, it would be difficult. And you can see that if we look at the size, the differences across regimes are broadly symmetric. So if you see low and low, low and low, low and low, low and low, high and high, so they are very kind of similar. But if we look at the sign, the differences within regimes are more apparent if shocks are relatively large and we start in high inflation regime. You see this, if we take a high and high, you see these numbers are quite different, right? So there is some asymmetry concerning the sign of shock. Why is that? Because if you start in high inflation regime and you have a favorable shock that drops energy prices by 40%, you shift immediately to a low inflation regime. Right? So that's essentially the mechanism that is working. And therefore, these the differences are not about the size, but essentially about the sign. Yeah, thank you. This is coming from the baseline. This is also coming from the baseline because you can subtract energy HICP from headline HICP, and therefore you get HICP excluding energy. So you get a differential effect that is very clear. Here instead, we add one of these variables in the model. So before we had, I think it's a 6-variable bar, the baseline. Now you have here 7, 7, 7. We add one at a time. And also core prices, there is a huge differential effect. Food prices is even larger. Here it's the impact on food prices is very important. Here you have 5. This is 2, 2. This is about 3. Instead, the food prices on the top of the credible set can even reach 5. So the impact of food prices is high, and we have noticed this, in the supermarkets that prices have increased quite substantially. Now, about wage growth, there is this story that there is this what is called technically, this price wage spiral. These second round effects, actually, they are called, in policymaker in speeches they talk about second round. So we look. So is there a second round effect? Means that wage growth goes up, prices goes up, they ask for higher wages and so forth. Now these are the second round effect. And first of all, is interestingly, even in low inflation regime, wage tend to rise. So it's slightly. This is we have data on year-on-year growth rate, so we cannot do much. So we plug the variables in terms of year-on-year growth rate. But clearly, after 1 year on the high inflation regime, the increase in year-on-year growth rate is larger than the low inflation regime. So there is also a kind of gap. And just if you want to really look at it, the difference, compared to the core inflation, there are no big differences. So it's kind of that wage growth is following a kind of core prices. But that's, there are two different measures. One is level, one is in level. But it's, for a policymaker, it could be useful. Very similar results in the case of inflation going, in case of favorable energy supply shock, they reduce energy prices by 10%. Now, we should expect some correlations with oil price shocks, it's a kind of validation of our results. And the correlations with the Kanzig oil supply shock is there, but the R-square is only 22%, okay? So the red dot are those after January 2021, I think it should be January 2021, or October 2021, I don't remember, I think January 2021. Actually, we should do October, so we can most likely, we should have also different color. But essentially, these red here are those during this crisis. So if we don't use the retail energy price, we are missing a huge amount of shocks. Okay, so that's the bottom line. Questions. Our working paper did not have energy production, we use energy-intensive production, which I think is an interesting variable. Energy-intensive production is a weighted average of basic metals and chemical. So the question is, it could be that is misspecified the model because you are not including energy-intensive productions, right? So we just include energy production with the negative signs, and the results are the same. Here we're comparing the baseline with this alternative model. The results are the same. What is interesting is that with the energy-intensive production, including industrial production, is close to zero even at the beginning, and also GDP. Even at the beginning, there is not this slight increase, which is a kind of unclear, but with the energy-intensive production, this problem is sorted out. There are some small differences, but the big picture is there. Energy-intensive production, and this industrial production, this is what talk about minus 10%. Industrial production is minus 5%. So the risk of deindustrializations in the chemical and basic metal is very strong. Okay. So we also, in the Russell check, we include a demand shock. A demand shock is to the narrative. We take the temperature when it is hot and when it is was hot in the summer and very cold in the winter. In these two periods, we play with this narrative, and the results are essentially the same. Alternative and basic model are very similar impulse response function. We also use a higher threshold in high inflation regime, 2.2, same results. We exclude the real GDP because it's got monthly data, and then we also exclude the shadow wage rate because it might not be needed. Results. So the model is scaled down to 4 variables, the results are the same. So these are the results. Summary, energy supply shock in the low inflation regime. Non-energy prices are sticky. We have all these DSG models with sticky prices that developed in low inflation regimes, and output drops. In energy supply shocks, in the high inflation regime, a persistent effect on headline core HSCP, high prices cushion the drop in output in the short term. So you have a steeper Phillips curve. Okay? And this has also been, actually Fabio was pointing in these directions. Sizes difference across regimes are broadly symmetric. Instead in size, there are asymmetries when you look at the signs. For policymakers, massive energy supply shock since October 2021, risk of a permanent drop of energy-intensive sector output. For DSG models, prices are sticky all in the low inflation regime. State dependent models on number of regimes might be required. Thank you very much.
Thank you. So, questions? Yes.
Thank you, Roberto. I have had an early understanding from the literature that estimates similar models such as yours, e.g. Switching local projection estimations or smooth transition threshold models for the threshold variables, which can be defined as a simple setup, e.g. pi t minus pi star divided by the standard deviation or variances, which differs from your setup. So if you can tell me whether this understanding is correct or not using this simple setup, in the sense that for the high inflation environment would be a state that exceeds this certain thresholds, vice versa for the low inflation environment. That would be my first question. My second would be, again, relating to IT again, inflation targeting. Assuming that the public inflation expectations are affected by depending on whether a country operates officially IT or whether a country is a non-ITer. Maybe for the US, it's much less so. But if I want to be dealing with Australian or New Zealand or the UK, I assume that if a country is under IT, the transmission mechanism from energy sector shocks or energy price shocks on the real sector of the economy might well be pretty different. So if you were me, if I were to use your model, how would you think you can incorporate this, if my guess is correct? How would you model this? Obviously without using explicitly a DSG model, a Taylor rule model, and obviously not using split sample, sort of analysis.
Concerning your first question on a smooth transition VAR, We are trying also to do that. There are complications. This lens aprimiceri, it's not a tricky thing to include. The advantage of the smooth transition VAR is that you don't set up a threshold. You have this logistic function that exists, but still there are parameters to be either estimated or calibrated. So it's not completely an endogenous process. But essentially, that is one point. The disadvantage of the smooth transition VAR is that it's here. If you look at the state dependence variance covariance matrix, it becomes very complicated. Let me just 1 second, and I'm with you. Okay, here, this one is very easy. Okay, because essentially, if you are in the low inflation regime, this is 0. You get the square root of this, and you can compute the square root of this. When you are in high inflation regime, this is 0. You get the square root of this, and you can estimate the standard some restriction can be done and or everything. When it is a smooth transition, so there is a logistic function also here, then you cannot estimate, you cannot provide, I think you cannot provide just an impulse response function in general. You can say this is the impulse response function in February 1994. So in February 1994, you have the computations and you compute the variance covariance matrix. So that's the reason why it is a bit more complicated. You can do that, but then you have to state the date for which IRF. Then you have thousands of IRF. One IRF in monthly data, you have one IRF for each month, right? So it's also very complicated which IRF. Here instead, it's easier. So that's as well. And so these are the two aspects concerning the smooth transition VAR. Concerning the inflation targeting, it's very difficult questions that you are asking because I think in inflation targeting, I believe that you should really move to a model. I think you have to go to ADHD models because in these VARs. There is an implicit error rule that is estimated, right? So if you plug GDP, you plug inflation, there is an implicit error rule that is there. And, most likely you don't want this, in your setting. In that sense, you really have to impose amazing restrictions. I never estimated in a VAR for a country with an inflation targeting. Obviously, you can say the data speak. It could be that they say that it's a truly inflation targeting regime, but it could be that instead they are, the VAR tells you a different story. Then if you are flexible in accepting that, then you go in this direction. Then you say, data speak. Then I think you can follow the same strategy. You impose here the target for the threshold, that you can estimate the two regimes in a similar fashion. Yeah, it's the same question of estimating data from the 60s with the United States. In the 60s, do we have a two inflation goal for the US? What is that? There is a discussion about that. People argue that it was not 2% inflation objective. Other people, Bianchi, for example, argues that the objective was there. We discussed this with the previous governor. He was mentioning that having a low inflation in his speeches, Burns, I think he was saying, we would like to have a very low inflation rate, but unfortunately, we have such energy shocks, right? So it's exactly the same discussion.
Thank you so much for your interesting presentation. I have one question. Recently, I came across a study by Miyamoto, Gwen, and Sergeyev. I think they are kind of talking about when the ZLB bonds, oil supply shock is kind of expansionary. But in your result, basically, low inflation regime, it's going to be contractionary. And then in the high inflation regime, if I remember correctly, at the beginning, it was something like a kind of expansionary and then going to be contractionary. So it's kind of completely opposite of what they found. So do you have something to say about this?
I don't know this paper, then you tell me also the name precisely of these guys because I could not understand. Well, our answer is, the Phillips curve becomes steeper in an inflation regime, and therefore you have a lower reaction output. Now, why positive? I cannot, test it. I do feel that there is one element where people are making, companies are making huge profits in high inflation regime. There is an element. I mean, I think they are able to convince everybody that they have to increase prices. And even if their margin or the average cost has not increased so much, particularly if the wage rate remains constant. So if they can make a huge markup, they will increase output. Okay. So, but this is, it's a proliferation of talk here. I cannot really prove it. From theory, we can say that there is. Now, if you take the other estimation that we include energy intensive output, then as I told you, exact here, you see that is zero. It's no longer positive. That's exactly what I meant before.
Just a quick comment on top of Munechika's. There was also this interesting response of the shadow rate in those same results that I think Munechika was referring to, which was going up, while at the same time having output going up. So definitely looking at the monetary policy rule or aggregate demand equation coefficients, I think would be kind of insightful to get at that. The
response of the shadow rate is consistent. It's very consistent with the Taylor rule.
It's just that despite the increase in the shadow short rate, you have an expansionary effect on GDP, right? Of course, it's consistent.
But it's all endogenous, right? So this is the exogenous variable, and so the question is why this happens, right? Now, this one, I mean, there is a differential effect on this. Certainly, in low inflation regimes, you are kicked with energy supply shock. You cannot increase prices. Your price markup declines. You reduce output. So you are in the flat part of the Phillips curve. Now, this one that they are positive, I'm not really happy that these are positive because I mean, I cannot prove that there is the one element that is there, as I said before, is that people are making profits. Companies are making profits during the high inflation regime because everybody can increase prices, even if their wages have not yet increased. So they say, you know what, but I cannot prove it. It would be nice to find a way to prove it, finding data on price markups, for example, but it's, monthly data is complicated. It's even the concept of price markup, in aggregate, there are no key statistics available there. Sorry?
Horizontal axis years.
Yes, this is, the data is monthly, but we brought it up as years. But the shadow rate is truly consistent with the Taylor rule.
Okay. Yeah. So thanks so much, Roberto. This is very interesting. One thing that I was thinking is that I mean, I cannot really wrap my head around the fact that there is this 2% threshold that kind of divides two states of the world so differently. And so I was thinking that maybe there's something else. Maybe just like it happens that you have found out a partition of the data that happens to kind of coincide or partially coincide with the partition that you found, but maybe the variables that explain these differences are others. So one thing that I was thinking is that if you have done any kind of exercise in terms of robustness, trying to, I don't know, work with a threshold with another variable, or just maybe thinking about a regime for expansions and a regime instead for recessions or something like that. I'm just curious, not saying that your work is not valid. I'm just saying whether
what we did is using a 2.2, right? We can change the threshold and looking at the various things. There is one issue is data. I still believe that you need a sufficient number of observations. From Euro area, we managed, and I stress, we managed to go back to 1990, okay? It was not straightforward to go back to 1990 with all these series. If you focus on your recessions, There will be very few data on resections. So one can try to think something, you know, to use the data in a different manner. But just focusing on some element like that becomes very difficult. The easiest thing that we can do is to see, you know, to move the threshold up or down and see when it breaks, right? So to understand that. But in terms of other type of configurations, I like the threshold to be the inflation is because you know, you can argue, you know, you could study the impact of yeah, we can do we can do, for example, you know, having GDP growth as a threshold measure, not necessarily recession expansion, because otherwise we don't have the data. We can have you know, low inflation versus high inflation rate in the same fashion. Then what would be the implications if we don't get any results whatsoever? Would be in support of these results, or would be we can do this, you know, certainly we can do this, but what would be your conclusions? Would be supportive of our analysis, or that would be the conclusion, right? Okay, we will.
Sorry. So I suggest to conclude the session, and thank you very much, Roberto. So since we are, behind the schedule, online. Okay. Yeah. Okay, break. No break.
They will be sitting on online.
So let's continue. I'm sorry.
And so the next session is on financial stability, market frictions, and energy security. And the first speaker is Ying-Tang Chan from the Normal University of China. And I don't know if he got connected.
We're going to need just a couple minutes just to swap over to the one.
Okay. So 2 minutes you can breathe. But you're not allowed